putting our results in a table. So in this example, it works in the same way. You've got this population, it's growing by 10%. So with compound interest, instead of a population of 10,000 frogs, it'd be $10,000 growing by 10%. Exactly the same idea. And so if we start with $10,000, 10,000 frogs, I should say, if it's growing at 10% every year, then if we work out what the increase is, so where's that 1,000 coming from? Yeah, it's coming from 10%, which is 10 divided by 100 times the original amount, which happens to be 10,000. So 1,000 frogs. And then the frogs at the end of the year, if we add the frogs at the start to the increase, we get how many frogs are at the end of the year. And then that becomes the new number for the start of the next year, and the same deal applies. We increase, the frog increase is 10% of that new amount. What is that figure going to be? Can we do that off the top of our heads? 1,100, yeah. And then we add the 1,100 to the 11,000. And so by the end of year 2, there is 12,100 frogs. That becomes the same amount at the start of the next year. And I have given you that 10% figure this time. And so then adding those two values again, keep going. Can you finish off that table very quickly? So yeah, so just over 7 years, somewhere in that 8th year, the frog population will double its original size. Where 214, yeah, that's a 4. All right, so now at that point, 21437, concerned about the increase in frog population after 4 years, no, not at that point, this point, 14641. Let me write that down before I forget it. The local council decided to use a new pesticide to kill off the frog population. This pesticide helped reduce the population from the 4-year mark by 60% per annum for the first 2 years. Determine the population 2 years after the introduction of the pesticide. See if you can finish off that table. So that is a percentage decrease problem this time. We need 1 to start multiplying again, or 2. So they decrease, so then that's the decrease, 60% of the figure at the start of the year. So once we've worked that out, take away that 60% figure and we get 5856. And then using that figure, 60% again, 3514. And subtract 2342. So at the end of the 2 years, we've still got 2,300 plus frogs, which potentially could bring that population back to where it was and then exceed it even further. Right? So, but anyway, that's where we're at, 2,342 or thereabouts. Okay? Seriously? All right, so really, if you can do up to the end of the frog question, that's all we need. The radioactive stuff was more for interest, just showing you the decay and how you can have things compounding in the opposite direction as well, and you still have that exponential curve. What I want you to focus on, apart from that frog question based on today's lesson, is the other thing from last lesson, which was depreciation and appreciation. So how things decrease in value. So that's like your decay that we just did today, and how things increase in value as well. I don't think we end up doing inflation actually, but it works in a very similar way to compound interest. Now, it's been recorded. You do have a practice test let's get out into the test revision section. You'll see it there. Practice test, test 5. There it is. So I will give you Monday's lesson to work on this, but you can see the sorts of questions that you could be asked, filling numbers in a table. Here's a graphical example. I was talking about graphs and so forth. All right, and there's something about frogs in there as well, interestingly. Okay, we'll leave it there for today. Thanks, everyone.